Hi everyone, and welcome to lesson 15.3. Today you're going to need the supplemental notes handout that's provided with the lesson, or make sure you have a notebook handy to take notes, and you'll want a pencil, probably a highlighter, and a calculator. So on the first page of the supplemental notes, something you see is the definition of a parallelogram, and a parallelogram is a quadrilateral with both pairs of opposite sides parallel to each other. For the sake of time, we often use this little parallelogram symbol for a parallelogram, so we don't always have to write that whole word out. Okay, so below it says parallelogram Katie is shown, and we want to talk about which angle is consecutive to angle K. So here's angle K. So there's going to be two angles that are consecutive to that. That's going to be angle Y and angle A, right? And we know that they are consecutive because they're next to angle Y. Now, our parallelogram, we know, has two pairs of parallel sides, right? That's the definition of it. So we have, for sure, KA parallel to YT, and we're going to know then, based on just that information, and then also obviously KY and ET are parallel, but what we know about the consecutive angles, so angle K and angle Y, or angle K and angle A, is that they are supplementary to each other. And the reason we know that they are supplementary to each other is because we know that the same side interior angles are parallel. So for instance, with K and Y, those are same side interior angles of our parallel line. So since they're on the same side in the interior, they're supplementary to each other. Okay, so definitely highlight that. That is the first of our many properties. Okay. Next, we want to talk a little bit about these diagonals here. If we drew in the diagonals for each of these parallelograms, so if we just draw in a diagonal for each of these, kind of pick your favorite one, what we're going to notice in each of these is that they divide it into two congruent triangles in each of them. So that's going to help us come up with some more properties. So if we have two congruent triangles in each of these, one thing we know is that the opposite sides of our parallelogram are going to be congruent because we have, those corresponding sides lining up. Those are going to be congruent, and these are going to be congruent. And we also know that the opposite pairs of angles are also going to be congruent. So for instance, here and here. And the reason we know that is we can prove that the triangles are congruent. Thus, what we can do is say that by our good pal CPCTC, we can say that these are going to be congruent pieces. So that's the reasoning behind them. So right now we're at three different properties of our parallelograms. So to use one of those properties, we're going to say, okay, here we have parallelogram LUCK, right? Parallelogram LUCK. And they're telling us that angle KCU, this angle right here, is 10x minus 15, and that angle K right here is 6x plus 3. So notice K and C are consecutive angles. They are next to each other, right? They're not across from each other. They're next to each other. So what we know about them is that they are supplementary. Had we had angle K and angle U, then they would have been equal to each other, right? Because the opposite angles are equal. So what we're going to do is we're going to take our two pairs of angles, 6x plus 3 and 10x minus 15, and because they are supplementary, we're going to add them up and set them equal to 180 degrees. Okay, so to solve, we would combine our like terms. We have 16x minus 12 equals 180. Add the 12 and divide by 16. X is going to be 12. Okay. Now, another piece here talks about this theorem here that the diagonals of our parallelogram bisect each other. So that's our fourth property. So what that would look like is that these would be congruent. The diagonals cut each other in half. They're not necessarily congruent to each other. They just cut each other into two equal pieces. So if we look at number 7, if we have parallelogram SCOT with diagonals that intersect at point Y, what we would say here is that we would first of all have to draw in point Y, and then SY is this piece right here. And then OY is this piece right here. Well, we know from the above information that our diagonals are bisected. So we know that SY is congruent to OY, and TY and YC are congruent. We know that about our parallelogram since that was given to us. So what we can do is set these two pieces equal to each other, right? Because we have 5 times 3x plus 2, and we said that OY was 9x plus 46. And again, we know that those have to be equal to each other because of that bisection, so we can set them equal to solve. So if we distribute this 5, we get 15x plus 10 equals 9x plus 46. Subtract the 9x, we get 6 x's. Subtract the 10, we get 36. X is going to be 6. Okay? So the next piece of this then is to stop and pause for a second to talk about all these properties we've now been over. So we've talked about trapezoids and kites in previous lessons, and now we're talking about parallelograms. And we want to kind of look at these and say, okay, well, why are they not the same thing? Well, the trapezoids and the kites do not have two pairs of parallel sides. So we would say that the reason that these are not going to be part of the same category is they do not have two pairs of parallel sides, right? Our kites have no pairs of parallel sides, and the trapezoids only have one, okay? So number 9 then, this next piece talks to us about the measures of angles. So if we know one angle in a parallelogram has 68 degrees, what are the measures of the other 3 angles? Well, the other 3 angles, if this one of them is 68 degrees, we know the opposite angle has to be the exact same size, right? Their opposite angles are congruent, so they're both 68. And then the other angles are supplementary, the 2 consecutive angles. So those would both be 112 because 180 minus 68 is 112. So the other 3 angles would have to be 68, 112, and 112 degrees since they're talking about angles. Last but not least, when we talk about sides, if we know one side is 12 inches and the other side is 18 inches, what would the other 2 lengths have to be? Well, they would also be 12 inches and 18 inches because we know that those are congruent to their opposite sides. So in summary, basically here, we want to talk about then all 5 properties we've talked about today. Number 1 being that the opposite sides of our parallelogram are parallel, right? AB is parallel to DC, and AD is parallel to BC. Okay. Opposite sides are also going to be congruent to each other, right? AB is not only parallel to DC, but it's going to be congruent to DC, and AD is congruent to BC, those opposite sides. Opposite angles are congruent to each other. So angle A is congruent to angle C, and angle D is congruent to angle B. While the opposite angles are congruent, right, we know that the consecutive angles then are supplementary. So they have to add up to equal 180 degrees. So angle A plus angle B has to equal 180, but so does angle A plus angle D. Angle B plus angle C has to equal 180, and so does angle D plus angle C. Last but not least, our 5th and final is that our diagonals bisect each other, right? So AE is congruent to EC because it's being bisected, and BE is congruent to ED because it is being bisected. Right? In our parallelograms then, again, if we have a couple extra questions here, what are our remaining angles going to be if we have parallelogram ABCD? Well, reminder, you always want to name these in a clockwise fashion. ABCD is our parallelogram. And if AB BC is 110, what are the remaining angles? Well, again, the opposite angles would be congruent. So angle D would have to be 110. And then 70 and 70 would be our remaining two angles because they are supplementary, consecutive angles to our given angle. Now, this also being said, all right, we need to be careful of our measurements. So because of this whole parallel factor, where we talked a lot about alternate interior angles, okay? So we know that the alternate interior angles have to be congruent, aka these curves, if you will, on the angle. Okay, so that's something to note. So if these were going to be parallel, this would have to also be 58 degrees, and then same kind of idea over here. We know with this Z that, these measurements are the same. So that's just something to kind of bring up as well. Now, in this particular problem, we're actually looking not for those alternate interior angles. What we're looking for is angle RUT. That's this angle right here. Notice that RUT is consecutive with this given angle because 58 plus 45 is 103. So we know that the 103-degree angle plus the angle we're looking for, RUT, have to equal 180 degrees because the consecutive angles are supplementary. So the measure of angle RUT after we subtract has to be 77 degrees. Now, the other bit of information they want us to solve for is y. Now, notice y is referring to the side lengths here and here. They are opposite sides, and we know the opposite sides are equal to each other. So we would set 3y equal to 18, and when we divide by the 3, we get our y to be 6. Okay, so our two answers there for example 2. All right. Now, we will definitely be working more with these in class. In particular, we'll be talking a little bit more about our parallelograms as well as filling out our family tree to keep track of all of these properties. But super important that you know these 5 properties because we will be using them a lot, not only with our parallelograms, but with rectangles and rhombuses as well. Thanks, everyone.